In this video, we'll discuss arcs and angles and circles. So we'll talk about the central angle. This is one of the primary angles we have in circles, and it goes from the center to the edge of the circle. In other words, it's made by two radii of the circle. The inscribed angle is made up of two chords. So that means that the 3 points to that angle are going to be on the circle itself. And there's a key relationship here, which is that the measure of that inscribed angle is always half the measure of the central angle that intercepts the same arc. So let's look at an example here. So say we have circle P, and we want to determine the following items. We want to know, what is the central angle? Well, the central angle is this angle that's formed at the center. So that would be angle RPS or SPR. The measure of that is given to us as 112 degrees. That means then that the inscribed angle, that's going to be the angle that's on the circle, that would be RQS or SQR. And that measure is always half of the same central angle. See, they're both opening to this arc RS. So we can say that we can take that 112 divided by 2 and say that the inscribed angles measure here would be 56. Now let's discuss what is an arc when we're talking about arcs in a circle. So an arc is a section of the circumference of the circle. And when we talk about the arc measure, we're talking about it as an angle measure out of 360 degrees. And it's the arc measure that's between that of the central angle that's intercepting it. And what we know is that the measure of the arc is going to be the same as the measure of the central angle. Now this creates two different types of arc measures. We can have a minor arc, which must be less than 180 degrees. And this allows us to use just two letters with a curved sign over top of those two letters. Whereas a major arc requires 3 letters. Now we can use that for any arc measure. It does not have to be a certain measure, but anything that's over 180 degrees must use the 3-letter form for the marking of the arc measure. So in this example, say that we want to know what is the measure of arc JH and the measure of arc JLH. So here we have a central angle, which is HKJ is 110 degrees. And what we know is that JH is that intercepting arc. So it has to have the same measure as the central angle, which would be 110 degrees. Then when we're looking at JLH, we're going to follow the direction of those letters and how they're listed. So we go from J to L to H. And we look and say, oh, that's all this other part of the circle. So if we think about that's opening to this central angle, and that is 360 degrees minus the 110 degrees. And if I subtract them, that would be 250 degrees. Now we can also talk about different relationships that exist within inscribed angles and their intercepting arc. One of the things we know is that because inscribed angle is half that of the central angle, it is also half that of the intercepted arc measure. And that gives us two relationships that we can use throughout these problems. One is that if two different inscribed angles intercept the same arc, then they have to be congruent. So say that I have these two angles, DWM and angle DZM, and I want to know what are their angle measures. Well, what I can see here is that they're opening to this arc DM, and it has a measure of 68 degrees. So let's start with DWM. Based on this original relationship, it has to be half of the arc measure. So half of 68 will be 34 degrees. And also the DZM opens to that same arc, so it has to be equal to the angle measure that I just found for DWM. Therefore, it must also be 34 degrees. Now, another relationship that gets constructed using these relationships is that the opposite angles of an inscribed quadrilateral will be supplementary. So what does that look like? So if you think about what is an inscribed quadrilateral, it's where all the 4 points of the quadrilateral are on the circle. And you can see that forms 4 inscribed angles. And so if I look at this problem, it says that we have circle A. We want to determine the measure of angle EUT and the measure of angle ELT. So we say, well, EUT is here, but I don't have the central angle or the arc measure. But what I can realize is that when I do that, EUT opens to this ELT arc measure. So if I add those two together, and then remember back up here that it's half of that because it's inscribed, I can determine that whole angle measure. So 101 plus 55 is going to give me 156. And if I divide that by 2, that tells me that angle EUT has to be 78 degrees. And then I want to ask myself, well, how do I get ELT? Well, that's the opposite angle of EUT, so they have to be supplementary. So the measure of angle ELT will equal 180 degrees minus the measure of angle EUT. And when I subtract them, I'll end up with 102 degrees. Now I can also look at arc measures with the tangent of a circle. And very similarly to many of these other issues when we're dealing with intercepted pieces, when we have a chord and a tangent intersecting together, the angle measure will be half that of the intercepted arc measure. So here is an example to show us what we're talking about. Here, ray FN is tangent to circle B, and we have chord NK here as well. And we know that the measure of arc NK is 130 degrees, and we want to know what is the measure of angle FNK. Again, this is that angle that is being formed. That's like the inscribed angle. So we know that it's half of that intercepted arc there, which is arc NK. So if I take a half of 130 degrees, I will get that the measure of angle FNK should be 65 degrees. Now, what if we have two intersecting chords? What we learn about these is that when they intersect, the angle formed at that intersection will be half the sum of the intercepted arc measures. So if we look at this circle with circle A and we want to determine what's measure of angle ECK, so a lot of people will say, oh, that opens up to 85. No, that's only if it's an inscribed angle. This is not inscribed. So what I have to do is look at both of those intercepted arcs, and I'm going to add them together and divide by 2. I have to take their average. And when I do that, 835 plus the 85 is going to give me 120, and then divide by 2, that's going to tell me that the measure of angle ECK would actually be 6. Now we can look at what happens to the arc measures and the angle measures when we have two secants. And what we know is that the measure of the angle formed by two secant segments that's outside the circle is going to be half the difference of the intercepted arc measures. So let's look at an example of this. So here we have this outside angle, and we see our two intercepted arcs. And we want to know, well, what is the measure of angle M or LMN? And so if I look and say, well, I need those two arcs, and I want to determine their difference and then divide by 2. So I'm going to do the larger minus the smaller and then divide by 2. And it has to be that direction because measurement is always positive. So 84 minus 38 is going to give me 46 degrees. And I divide that by 2. That would tell me that that angle measure of LMN out here, this angle right here, is going to be 23. Now we also have relationships between the radii, the chords, and arcs. And what we know is that if we have a radius in a circle and it's drawn to be perpendicular to a given chord, then that radius is going to bisect both the chord and the chord's intercepted arc. And that's both the arc measure and the arc length. So say we have this image here where we have circle L, and we want to determine what's TU and the measure of arc TU. And what we see here is that since we have L as our center, RL represents a radius, and we have an image construction so that RL is perpendicular to TU, this chord. And so what that tells us is that TN is going to equal NU, and arc TR is going to equal arc RU. So let's mark those pieces as well to help us before we get started. So we know that the measure of arc RU has to be 56 degrees, and we know the measure of segment NU will be 11 units. So now let's talk about the measure of arc TU. TU goes from T all the way to U. So that's going to be the sum of my two smaller arc measures. That's 56 plus 56, which is 112 degrees. Now let's look at TU. TU will be the sum of my two smaller segments. That's TN plus NU. That's 11 plus 11, which is 22 units. And finally, let's talk about arc length. Arc length is the length of the circumference between a central angle. So when we think about this, the way we can write this is that the circumference of that portion of that makes up the arc length is going to be equal to the arc measure over 360 times the overall circumference. In other words, it's a fraction of the total circumference. So if you, just to remind you, circumference can either be written as diameter times pi, or that's equivalent to 2 times the radius times pi. So if I have this example here where they say, let's determine the arc length of GE in circle T. Let's go through and mark the parts I know. I know the radius is 9 units. I know the arc measure would have to be 60 degrees because the central angle is 60 degrees. So now I can use my formula and use the one that has the radius, which is right here. So I can say that the length of arc EG is going to equal that arc measure over 360 times 2r times pi. So the arc measure is 60 degrees, and then it's 2 times the radius, which is 9 times pi. 60 over 360 simplifies to 1/6, and the degree units simplifying each other, and then 2 times 9 is 18. So a sixth of 18 pi would tell us it's 3 pi. That's the length of arc GE, and that's 1/6 of the total circumference of this circle.